to approximate the area under a curve using rectangles. And we're going to end up doing this graphically to start. So they ask us, it says the graph of a function is shown below as a blue curve. Create a visualization of a left endpoint approximation for the area under the curve on the interval -4 to -1 using 4 rectangles. So a left endpoint approximation means we're essentially going to take the left endpoint of each rectangle and we're going to attach them to the function. So these are going to represent our areas that we're adding together, and we're going to take the left endpoint, attach it to the function. Part of the rectangles will be outside or above the curve, and then the rest of them will be under the curve. And so we're trying to find an approximation for the area under the curve. -4 to -1 are the endpoints for our domain, or the area that we're trying to find. So we're going to set up our vertical asymptotes on -4 and -1. And we're using 4 rectangles. They already have 4 rectangles set up here. So we're going to take the left endpoint of the first rectangle and we're going to put it right on the function. And we're going to take the left endpoint of the second rectangle, put it on the function. And the left endpoint of the third one. Finally, the left endpoint of the last one. And they should all be on the function now. So this is going to represent the area under the curve. You can see it's going to be a little bit of an over approximation here because we have some parts of the rectangles that are leaking over the top. But it should be a fairly accurate depiction of the area under the curve. Let's try and do one more of these problems. It says the graph of a function is shown below as a blue curve. Create a visualization of a right endpoint approximation for the area under the curve on the interval. It looks like the interval is going to be 0 to 4 using 4 rectangles. So we're going to make our asymptotes, slide our asymptotes over. So we end up with 0 to 4. And this time they're saying they want a right endpoint approximation. So they want the right coordinate, or the furthest right corner of each rectangle to be touching the function. So we'll just set these up so that the right corner is touching the function for each of these. And you can see this is going to be an overestimate for the area again. And this one's not quite as close because we have quite a bit of overlap outside of the area under the curve. But it's still going to be a fairly decent approximation.